Let's now solve a few questions, exam questions about parametric differentiation. The first of which is this one. It's from winter 2013, question paper 31. And it says the parametric equations of a curve are x equals e to the power minus t cosine of t. So it's here the parameter, it's t. And y equals e to the power minus t sine of t. Show that dy by dx equals tan of t minus pi over 4. So in order for you to differentiate this, you just have to apply the rule to differentiate, which is this one over here. Dy by dx is dy by dp, in which p is the parameter, which is t in this example. The whole thing divided by dx by dp. I always like to put things within these curved brackets because I have everything in front of me. Applying the formula adapted to the parameter, which is t. Differentiating this is just applying the product rule. So again, the first one as is times the second one differentiated plus the second one as is times the first one differentiated. Same thing on the denominators. So the first one as is times the second one differentiated plus the second one as is times the first one differentiated. I expand these brackets. I just factorize the e to the power minus t and cut it out. And this is what I get. Don't forget what you want. You want that. We're still far away from it. You have sines and cosines, but what you want is a tan. So what you need to do? You need to divide both numerator and denominator by cosine, so that you have here sine over cosine, which is a tan, and the cosines are going to cut out. That's what I did over here, all right? So sine over cosine is tan, minus cosine over cosine, which is minus 1. Sine over cosine is tan of t, plus cosine over cosine is 1. And then we are getting closer, right? But you still have a pi over 4 over there. So how do you get the pi over 4? You need to remember that 1 is the tan of pi over 4. So that's what you put over here, okay? And then eventually you are going to see that this is, you have this in the IMF 19. This is basically the outcome of the formula 10 of the difference of two angles, right? So you would reach over here and you would immediately understand, because you have solved enough questions, that this is the formula for the tan of the difference of two angles, in which one of the angle is t and the other angle is pi over 4, and you reach what you wanted. Second question. This is a paper 2 from June 2007, and it's question 3. The parametric equations of a curve are x equals 3t plus natural logarithm of t minus 1 and y equals t squared plus 1 for t bigger than 1. First sub-question is to express this, the different dy by dx in terms of t, and then find the coordinates of the only point on a curve at which the gradient of the curve is equal to 1. Let's go there. Again, here you have the two expressions in terms of t. Differentiating them is dy by dt by dx by dt. So differentiate this. This is just 2t. Differentiate this. This is 3 plus 1 over t minus 1. Let's simplify this, getting the same fraction on the denominator. Then applying the tire rule or whatever method to get this expression, and that is the answer for the first sub-question. Then the second one, again, you wanted to find the coordinates of the only point on a curve at which the gradient of the curve is equal to 1. So if the gradient is equal to 1, you just equal this expression for all gradients to 1 and solve it, all right? This is what I'm doing over here. So I'm combining like terms. Eventually I have a quadratic. I can factorize this quadratic, and I will get eventually the result t equals 2 or t equals 1 over 2. The question in the beginning said that t is bigger than 1, so this eliminates this answer. So the only answer is t equals 2. Now that I know the value of t, I just substitute it on the original equation, and I get the coordinates of x and y, thus the coordinates of the point. Next one is this one over here. It's from June 2009, paper 3, and the question is question 6. The parametric equations of a curve are x equals a cosine cubed of t and y equals a sine cubed of t, where a is a positive constant and t is in between 0 and pi over 2. First, again, express dy by dx in terms of t, and then show that the equation of the tangent to the curve at a point with parameter t is this. And finally, hence show that if this tangent meets the x-axis at x and the y-axis at y, then the length of xy is always equal to 1. Let's first differentiate it, applying the formula. So if you differentiate this, this is going to be, well, you can apply the chain rule. This is going to be dy by dt is going to be dy by du times du by dt, in which u is sine of t. If you apply this, I already did this mentally, so I can just plug in the values over here. So it's going to be 3a sine square of t times cosine of t. Do the same thing over here. And the result is going to be 3a cosine square of t sine of t. Simplify everything that needs to be simplified, and eventually you just get minus 10 of t. Then you have to, again, what was the question? It's not this. Yes, it is. Show that the equation of the tangent to the curve at a point with parameter t is that one. Okay, so you already know the gradient. The gradient is minus 10 of t. So in this general point over here with parameter t, this is going to be the y-coordinate, this is going to be the x-coordinate in terms of t. So plug in the equation of the straight line, y minus the y-coordinate equals the gradient times x minus the x-coordinate. Expand these brackets over here, and then try to simplify until you get what you want, which is this. All right? Should always keep an eye on the ultimate result so that you organize the terms in the way that the question is asking. So right now you are over here. So first of all, you don't have anything with 10, so you have to turn 10 into sine over cosine. Same thing over here. So this is where you are right now. And eventually, to get what you want, you have to multiply all terms by cosine of t. And realize that this is just 1, and you are done. Yeah, just pass this to the other side, and then you are done. You reach what you want. Now you know that the points that they are talking about here in linear 3 are the x and the y intercept. All right? So substitute y by 0 to get the x-intercept on the equation, and eventually over here, if this is 0, you just have this equals that, and eventually you have a x equals a cosine of t. So this is the y-coordinate, sorry, the x-coordinate. And for the y-coordinate, you just substitute x by 0 in this equation, solve it, and you have y equals a sine of t. So you have there the y-coordinate. The distance between them, you just apply the formula for the distance between 2 points on these 2 generic points. Then you solve this, factorize a squared. This is going to be equal to 1. So square root of a squared is a, as required on the question, always equal to a.